This time I've got a Panasonic microwave oven. This is an inverter type, but it doesn't matter because they're all the same. We have a problem with the door latch on this. Specifically, the door won't close properly and it's bending the chassis. And the guy that owns it, he tried to Mickey Mouse it, and well, this is how not to fix it. I'll show you what goes wrong with these ones and how to deal with this problem because it is quite common. So I got a microwave oven to look at. Apparently there's a problem with the way that the door switches are not working or working. Fellow says it doesn't, door switches don't engage properly, and that the bracket is bent. It's the best way to describe it. So the owner of it's been into it, so he asked me if I could take a quick peek, see whether it's something that can be resolved. Of course, I've got security bits. Gotta find my. Is this one gonna fit it or not? Of course not. Good old T20. That's more like it. These are the security bits with the pin, so you need the T20 with the hole in it. Actually, yeah, these ones do have pins on them. Panasonic thought that would keep people out of them. And of course the one on the side is just a regular Phillips. Okay, be careful when opening these units up because the metal here is sharp as a knife. Good way to get cut. Believe me, that's happened before. Oh, what has he done here? What the hell? Like, what? Really? What is going on with this bracket? He says the switches aren't making contact. They're not closing. Let's take a look and see what's going on. What the? This is getting worse. He's got wire. What the fuck? I almost said it. I almost swore. What the hell is this? Like, what the? I kid you not. I kid you not. Wire wrapped around the switch block. So what he says is that when you close the door, it bends and doesn't close properly. And the reason it bends and doesn't close properly is probably because the door hook is broken. More than likely this piece over here. Instead of it closing properly, so the fellow that owns it figured if he just bent this over, that it would solve the problem. Let's just see what the real problem is. Why are the alignment off on the door switches? Again, it's probably because the hooks are bent, which happened on these. This one actually almost looks like it's twisted a bit. Maybe not, but it shouldn't be that difficult to close the door. If it's out of alignment, it's a problem with the door hook itself or the bracket. So first things first, we'll remove the bracket. I'll unplug the switches too, so I can just get into this entire switch block. I'll just take out these screws. we look down at the bracket, it's bent. You can see this has been twisted. This is very thin metal on these units, right? It always has been pretty thin metal. And it will bend if the alignment is not correct and the switch hooks hit the side instead of going in. If they hit the side. Now what quite often happens is these wear, and you can see the wear marks on here, right? This block wears out, this plastic piece wears out. The switches go in like this. It drops into place. As this wears out, they tend to hang up more, and you get a groove in there, and you can see that there's already a groove wearing in here. So it's probably this switch block is what's causing the fault. And it got caught, and when the door was pulled, it bent the metal, because the metal itself is really thin. That's usually what happens on these. When we were repairing these units, we changed tons of these switch blocks. Not an expensive part, well, at least it wasn't at the time. I don't even know if you can get them anymore, but we used to change a lot of these switch blocks and the door hook itself, because these do wear out as well. Usually when they break, like when they're gone, they usually break. The plastic breaks. This one has not broken. It seems to be okay still. See if I can get this realigned and get it installed and get the switch operating properly. So on the door, when the door is hooked in place, the door hook goes in like this, and it latches to hold the door shut. When you push the button in, it pushes this bottom catch up, which raises up these catches and allows it to unlock. What's happened is, looks like the metal frame here has gotten bent, and this is out of position. So the door catch is actually hitting the side here instead of going into the slot. So we need to get this shifted over a bit, and I can see that there is a bow in there. I think what I'll do is I'm going to remove the timer assembly just so that I can access the oven a little better, the metal, and that way I can see the alignment a little easier with this off. So I'm just removing the screws that hold the timer board in place. That should give me enough slack to work on, I think. Alright, now I can see this bracket that is kind of deformed. See if we can get this straightened up. If we do look down here, this hook is actually bent a bit. It's leaning in this way. That should be more straight, but you can see this hook has got a bend. Now if we can heat that up, and maybe we'll put some heat on that and straighten that up a bit, because you can definitely see there's a bow in this bend here, so I'm going to throw some heat on there. Okay, I've mounted the bracket back. I do believe the switches are closing now, and the doors is closing. Let's see here. I release the switches. Yep, the switches are latching. Ha ha ha. Okay, let's put the panel. Let's put the control panel back on, and hook up the wires and see whether it works. Now we can test this unit and get it out of here. Put that back in place. And that snaps in. A couple little catches on the bottom, but lock that in, and then there's the 2 screws on the top. So what the problem was on this was this top hook had a bend in it, so it was catching. That's what basically I straightened out the metal that was bent, and I kind of bowed that hook back because you could see it was physically warped in, and that will cause problems every time. Hook up my switches again, get the appropriate connections on. There's one, and then there's the monitor switch. This is the one that will blow the fuse if things don't open in the right sequence or if switches stick shut. So this is the back switch, and then the front switch, this has the 2 wires on it. That's the timer control switch. That basically stops the timer when you open the door, and it had 2 wires going onto it right here. Doesn't matter which one they go on either. It's just a normally open switch. All this one does is signal the timer that you've opened the door, so that it doesn't continue to count down if you've opened the door to check on something. And it also tells it to stop, so that when you close the door it doesn't start right up again until you push the start button. Okay, I think it's time to power this thing up and try it out and see if it works. Okay, I got a cup of water in the unit, powered up with my heavy duty extension cord. And of course the light will come on because the door's open. And let's just how do we work this thing? Let's see here. How about quick minute? This is when you want to keep your fingers out of this area here, because it's about 4,000 volts. 4,000 volts on this connector from this inverter. So when it's operating, keep your fingers away, because I've been belted by that before, and believe me, it was not fun. I think I've told the story before, but I'll tell you the story again. So about, I'm going to say 35 years ago, I guess now. It was at least 35 years ago, because we were in the first shop that I worked at. So I'm trying to think. I started with them in 1984 after my tenure at Sony was over. I was at Sony for a year, then I went to this shop called Jack's Radio. It was a warranty depot. It was a small shop. It got much bigger the time I was there. But anyway, this was in his first location, located right next to a Greek restaurant. And the Greek restaurant would bring their crap over all the time to fix, including their microwave oven. All the restaurants used to bring all their crap to us. Oh yeah, it's hot. Ow, damn. Steaming. It's steaming after 1 minute. It's warm. So yeah, it's working. Anyway, where was I going? Okay, so magnetrons would fail from time to time. They always do. And they fail. This is before we had inverter microwaves. They were just the conventional transformer. So you had your high voltage transformer. You had a high voltage diode called a stack diode, and a big capacitor, 2 microfarad, 2,000 volt or 3,000 volt or whatever it was rated at. But it's up there. It was increase the power factor. And then your magnetron, one side is grounded which is grounded to the cabinet. So the two red wires would make one of them would make one loop around the transformer to deliver about 1.5 or 2 volts AC to heat the filament at high amperage, because filament took a lot of current to heat it up. The other one went to the capacitor. So there was basically between 2,000 and 4,000 volts on this connector at all times, with about a 2 volt AC difference between the two. Anyway, you had your high voltage and your filament voltage, and sometimes these would short. And when they shorted, obviously they're not going to heat, but it's going to draw way too much current and it's going to blow the fuse. So we disconnect the magnetron, take off both wires. Got to do both, because if it's shorted, it'll short through one side or the other, because both of these were connected together, right? One side, I'll draw the diagrams just so I can more easily explain it to you guys. So here's your basic drawing of a conventional magnetron. You've got your primary side here, 120 volts. And then this one here had, say, 2 or 3K. We'll call it 2K. The inverter ones have higher voltage because they have higher power. But your conventional, like 600 or 700 watt oven, be about 2,000 volts. One side of that transformer is grounded. It's actually grounded right to the iron core. So there's no second wire. This is grounded to the iron core, which is screwed down to the unit. So it's grounded. The other side went into your power factor increasing capacitor, which increased your power factor to, otherwise it would just draw so much power it would blow a fuse. So it kind of isolates the transformer from the magnetron. There's your diode, which gives you your plus, your B plus for the magnetron. That goes over to the one marked FA, which was filament and anode. There's a second lead, a red lead, that wound around, made one turn around the core of the transformer, and it went from one that was connected here to the anode and filament, made one loop around, and then went to the other side. So you'd end up with your 2100 volts or whatever it was, or 2500, whatever it was after rectification. And then on the other side, you'd also have, because they're both connected together, you'd also have 2100 volts over here, but you'd have AC, maybe 3 volts or 2 volts or whatever, however many turns it was around there, and that would be dependent on what the requirement was the filament to the magnetron. So obviously if you just unplug one, well, inside here, the filament is inside the magnetron. If this was shorted, that's what we're looking for. We're trying to determine, is this shorted to here? And no, you can't just measure it with a meter. If it was a dead short, yeah, you could measure it, but it might be a high resistance short, which won't show up on your meter, but when you apply power to it, it starts arcing internal. That's what we're getting at, is it arcing internal? And you don't know until you put power. So we would disconnect the magnetron, and of course you could measure it with a meter to see if there was any shorts. Normally you'll see resistance between the two terminals, but you'll see nothing going to the case. So if I grab the meter, we measured across here, we expect to see the filament. If you measure across here and it's open, it's 0.2 ohms, but if this was open, then okay, the filament's gone, right? If you measure across here and you've got a dead short, well, the magnetron's got a short between either of these, right? It should be open, because this is a tube. But the problem happens is, what happens when it breaks down under load, which is what happens. Sometimes it'll break down under load. So we would disconnect the two leads and then power the unit up. This is where it gets sketchy. You see, this is not an insulated, this is a no-no. But this is kind of like the pliers that I had at work. I had some insulated pliers, but the handle had cracked on it. And I pleaded with the boss, the owner of the shop, because at the time I was a junior guy there. I'd only been there a few years. I'd maybe been there for 3 or 4 years. I know that when I started at the shop, 84, I think 88 we moved to a new shop. and had to pack everything up. So it was between 84 and 88. And I got my assistant working in the shop, good old Marv. And Marv wasn't a technician, he was a helper. He would take things apart and put things together for me. And this saved me time, right? So I could just do what I did. And he would hand me something that was in pieces. I would fix it and I would ship it back to him and say, here, put it together. Anyway, we're going to test this. Now remember, this is going to have high voltage on it. We're going to do this powered up. I'm not going to do it here because there's obviously nothing wrong with this, but we would take our insulated pliers, something like this, and no black tape wrapped on the handle is not insulation, because what happens, you get moisture on here from holding it, and the moisture will get in underneath the tape. So normally we would grab the wire like down here, where it's insulated. We wouldn't be hanging on to it anywhere up here where there's metal. We would grab the wire down where it's insulated, turn the microwave on, and just bring it close like that. And if you got close and it started to spark, you started to pull an arc, especially if you touched it. If you touched it on there and you got an arc right away, you got a problem, because there should be no current flow. Because remember, even if I put that on without the filament providing current to heat up the filament, the magnetron's not going to conduct, right? Because you need that filament. It's a vacuum tube. But we would turn it on and carefully just bring the lead in close, touch it, hanging on to the insulation part back here. And I guess what had happened was my assistant, who I told him, don't talk to me, don't disturb me, don't interrupt me when I'm working on a microwave, because this is not on an isolation transformer when I'm working on a microwave. Isolation transformer cannot provide enough power to power it up. It's plugged directly in. So you're working with one hand in your pocket. You always keep one hand away from anything that's energized. This is for safety. You see, you can get a shock if your hand is, say, touching something metal. In this case, I was reaching into this old microwave. It wasn't one like this where the magnetron was on top. It was a big, I think it was a big Amana, and you had to reach inside, quite a ways inside. My hand was touching against the metal frame. So that was giving me a ground right there. And as I was maneuvering the wire, I guess I got distracted, and Marv called my attention to something, and I kind of looked over, and as I looked over, I wasn't paying attention. The pliers slipped and got too close and made contact with the metal. And these old microwaves didn't have these nice plastic high voltage connectors. They typically had metal ones that were completely metal. And anyway, or metal with a little boot over them, like this. This is what they were, more like this on the light bulb, like that. Right? That's what they had. Anyway, what happened was I got jolted. And because my hand was in contact with the metal chassis when I got jolted, my hand clamped down. And you can't let go. And believe me, you cannot let go. Now, I wasn't being electrocuted because my other hand was in my pocket, and I was wearing insulated shoes, rubber sole boots, and I was standing on a rubber mat. We had a rubber mat in the shop on the floor. So as long as I kept my other hand away from it, there's not a chance that I'm going to get electrocuted, but I'm going to get an electrical burn from my hand, right? So the only thing I could do was jump, and because it didn't affect my legs because there's no current getting past my wrist, but I had to jump, and I jumped, and I landed on some TVs that were stacked up. We were in such a cramped shop. The TV shop looked as bad as this. It kind of looked like that in the back because we had so much crap in for repair. And I had a workshop that was, I think the shop was maybe smaller than this garage. This is like 240 square feet. And the workshop was probably only 200 if we're lucky. It was small because the shop owner wanted the most amount of space for his showroom, not for the repair department. And we had tons of TVs, and these were in the days of these great big console sets that were like 6 feet long, and we could fit 2 or 3 of them in the shop. So we would stack stuff, kind of like I've got stuff stacked here. We would stack stuff on top of other TVs. And when I jumped back, I had a workspace about the same amount of space I've got here, believe it or not. We had a cart that I could wheel around, but you know, I had a bench and I had a cart. In fact, the cart is right here. I've got the cart. My TV sits on it. That was my cart from the shop. Anyway, I jumped and I landed. I hit a stack of TVs that were sitting on consoles and knocked over a Sony Trinitron. My asshole boss, let him rest in piss, actually made me buy the owner of the TV. The bezel got broken around the picture tube. The TV was fine, but the plastic bezel got cracked and the part wasn't available. So my a-hole boss basically deducted the price of a new TV and gave it to the customer and then told me I could take the old one home. I still have the TV, by the way. I can show you the TV if you don't believe me. I can show you the TV with the crack in it. I've got it, and it still works. But anyway, that was my story on getting jolted from a magnetron power supply when it was operating. So yeah, keep your fingers away from this thing when that thing's powered up. They don't hold a charge, okay? They do not hold a charge when it's off, because the high voltage capacitor has a bleeder resistor inside that will drain capacitor down within maybe a minute. If you were to charge it up and turn it off and then put a meter across it, you'd watch it drop down. It's quite a high ohm resistor built in. It's in the mega ohm range, so it takes a minute or so, but it will completely discharge that capacitor. Same with the ones on here. These ones have very small caps because it's an inverter. The voltage is dead within seconds of the thing being powered off. So they're not as scary to work on as people would assume, because unless you're sticking your fingers in with the high voltage when it's on, which is never advisable. You know, we did it to determine if the magnetron was shot. And that was a quick way to determine if the magnetron had a short. Would you disconnect the leads and then you'd bring, with it energized, you'd bring one up and bring it close and see if you would draw an arc. But just like when you're, you know, they say do not ever talk to, you know, a power line technician from your electrical company if they're working on a pole or something. Don't talk to them, right? They'll yell at you. If you try to ask somebody a question working with a hot stick or up in a bucket, they'll basically yell at you, and it won't be pleasant, the language that they use. They'll basically tell you to F off and to not talk to them, because anybody that's working around high voltage, you need 150% attention as to what you're doing, because you only get one chance. And if you make a mistake, it could be the last mistake you ever make. And the first rule when working around high voltage, whether it's on a microwave oven or a CRT television, where you're working around anywhere that's energized that has high voltage, one hand in your pocket. Work with one hand. That way, the worst thing that can happen is you can get a shock through your hand. Like if your arm is leaning or resting on something, you can get a shock. I got nailed by a CRT second anode doing convergence exactly the same way. In fact, you can still see the scar. If I zoom the camera in here, there's a scar on my thumbnail right there, where my thumbnail got. That was, it doesn't show up that well, but see the line here? That was caused by when I got zapped. The power went out my thumbnail. I was on the CRT adjusting the convergence magnets. Same guy, same helper. He did the picture tube replacement, but he didn't know how to do convergence. So he bolted the picture tube in. And the dumbass, I don't know how many tubes we'd changed. We did a lot of tubes. He neglected to clean the inside of the high voltage cup and the glass around the second anode. And because there was dust and dirt and crap on there, it allowed the air to ionize because it wasn't sealed. It allowed the air to ionize, and as I was reaching, I wasn't touching it. I was just close to it. But my hand, where I was adjusting the magnets on the picture tube, was I think probably resting on a ground strap or something down there. Anyway, all I know is I heard a loud crack, a snap, as it arced, and it arced into my arm and out my thumb, and that felt like I had hit my thumb with a hammer. That was the best way to describe it. It was throbbing like I hit it with a hammer, and no burn or anything, just a big loud bang, and yeah, it hurt like hell. So those were my two instances with electricity that I would rather it be the last one, because it's not pleasant getting a jolt, I'll tell you that much. Anyway, this one's, say, fixed. Let's throw it together. Incidentally, this problem that I showed you with the door hook is quite a common fault on these units. I've done many of them over the years. Not lately. I don't work on a lot of microwaves these days, but I've seen that many times. The bracket, the hook. Normally we would just change the hook, but I don't know where you're going to get one now. When Panasonic had a service department and parts department up local, we would just call them up and say, hey, I need a door hook for such and such a model. And we'd usually change the switch block as well. The bracket that wears, we'd change the switch block, and we'd change the door hook. And that would fix it. But now that these parts are getting hard to get, unless it's actually snapped, put a bit of heat on it with a heat gun, heat it up a bit, make it soft, bend it back into shape. Alright, this one's back together, and the door is opening and closing exactly as it should. Thanks for watching.